Hi students, welcome to this today's class. So in the last few classes we have discussed about the limit, differentiation, continuity and differentiability, and now we are going to see a very important topic, that is applications of differentiation. Okay now. So what are the uses of, so far we have learned differentiation. What is the use of that differentiation? Let us see. So the major use occurs in finding the equations of tangents and normals. Tangents and normals to a curve at a point. So what is that? So let us see this. Let us consider a curve y is equal to f of x. Let us take this x-axis and y-axis, it is an origin. Okay, consider a curve y is equal to f of x. Y is equal to f of x is a curve. Okay now, right. So for this, let us Px comma f of x be a point on the curve. Px comma f of x is a point on the curve. X comma y, y means how much? F of x. So a tangent is a line which touches the curve at one and only point. So this is called tangent. This is called tangent of the curve y is equal to f of x at the point P x comma f of x. Let us consider a curve y is equal to f of x. Let us consider a curve y is equal to f of x. Okay now. Let Px comma y, let Px comma f of x be a point on the curve y is equal to f of x. At P, let the function is differentiable. Let the function is differentiable means what? We can draw a tangent at the point P. So let this be the tangent at the point P. So this is a tangent. Okay now. Now Px comma f of x is called point of contact. Px comma y is called, so this point is called point of contact. Point of contact. We call it as a point of contact, tangent. So tangent is a line which touches the parabola at one and only one point is called a tangent. Now coming to one more concept that we are going to see, that is normal. What is normal? Normal is a line which is perpendicular to the tangent and passes through the point of intersection, point of contact. So this is the normal of the curve y is equal to f of x. Here Px comma f of x is called the point of contact. So this is the tangent and it is a normal of the curve. Okay now. Now to find the equation of the tangent or equation of the normal, we require two things. One is point and slope. One is point and slope. Point is clear, x comma f of x. Then how to find out the slope of the tangent? That is a very basic use of the differentiation, finding the slope of the tangents and hence the slope of the normal. Okay now. So that is very important. Now the slope of the tangent, that is m is given by the derivative of the function at the point x comma f of x. The derivative value of the function y is equal to f of x at the point x comma f of x. That means what? Given the curve equation, differentiate, that means find the dy by dx and substitute this point in the dy by dx, then you will get a one numerical value you will get, that is called slope of the tangent. Understand? Yes, as usual we know, if tangent and normal both are perpendicular, if the slope of this tangent is m, the slope of the normal is minus 1 by m. That already obvious. We know that from the coordinate geometry. Okay now. So this is the slope of the tangent, and we know the slope of the normal. Okay, tangent and normal equations we can find out using the tangent normal. But while defining tangent, there are very important note points are there. Let us see that note points. Okay, welcome to this note points on this tangent. Note points on this very important note point is, let us take this x-axis and y-axis. Okay, now there is a curve, it is like this, there is a curve like this. Okay, now there is a curve like this. At a point P, there is a tangent. There is a tangent. So you may ask one doubt, sir, you said that the tangent is a line which touches the curve at one and only one point, but again it is intersecting, sir, it is intersecting the curve again at some Q. Even then, this is called tangent to the curve. This is called tangent to the curve at the point P. Okay, now this is called tangent to the curve at the point P. Okay. Okay. So this is one of the very important note point. That means what? A tangent can intersect the curve at any number of points, but it should touch the curve at one and only one point. Okay, now for example, if the line is like this, if a line is like this, see here, it is one point here, one point here, it is intersecting, this cannot be called it as a tangent. For example, here it is touching the point at, and it is a join here, as it is a tangent at the point A. That's all. It may intersect the curve at again any number of times. Okay, now. So this is a very important points. Okay, now. So I hope that you understand this point. Let us see one more note point. Let us see one more very important note point here. Very important note point. X-axis, y-axis. For suppose there is a curve is like this. There is a curve is like this. Now at this point P, this is a tangent. We can call it as a tangent. This is called tangent. So you can call me, sir, you said that it touches the curve, but if you see here, so this is a one type of special curve. Even then it crosses the like this, that means it is touching up to here, again it is touching the curve like this. Then also we can call it as a tangent to the curve. Okay, now. So let us see one more point. See here, note 3 points. So let us consider a curve y is equal to x power 2 by 3. Let us draw, find the slope of the curve tangent at the point 0, 0. So let us see the derivative of dy by dx is equal to how much? 2 by 3 x to the power of 2 by 3 minus 1. This is minus 1 by 3. So that means what? 2 by 3 cube the root of x. So what is the slope of the tangent dy by dx at 0, 0? See here, substitute 0, 0 here. So definitely it is not defined. Even though dy by dx is not defined, the tangent exists for the curve at the point, but or maybe that point. How, sir? Let us see the graph of this curve. So this is equal to x-axis and y-axis. Y is equal to this, the curve will be like this. So y is equal to x to the power of 2 by 3 curve is, it is of the form this, which is a y is equal to x power 2 by 3 curve will be like this. Okay, now. So now this not defined means what? It should be a vertical line at x is equal to 0. It should be a vertical line at x is equal to 0 means what? Nothing but y-axis. This is the tangent. Here y-axis acts as a tangent. Okay, now. From this example, what is the conclusion that we have to understand means, even though dy by dx does not exist, even though dy by dx at a point does not exist, it is not defined, then there is a possibility of existing a tangent at that point. Okay, now there is a possibility of existing a tangent at that point. So it is not the question of either dy by dx will exist or not exist. Even though it does not exist, there is a chance of having a tangent at that particular point. Okay, now so I hope that you understand this concept. Let us see some basic small problems which have subject knowledge. Let us see this. Prove that the tangent drawn at any point to the curve f of x is equal to x to the power of 5 plus 3x cube plus 4x plus 8 would make an acute angle with the x-axis. Would make an acute angle with the x-axis. Let us see the solution. So f of x is equal to how much? X to the power of 5, 3x cube plus 4x plus 8, it is k. Now let any point, arbitrary point x comma y, let us find its slope. Slope means what? Slope of the tangent f dash of x. What is f dash of x? So this is equal to 5x to the power of 4, 6x square, 9x square plus 4. If you observe here, 5x to the power of 4 plus 9x square plus 4, it is strictly greater than 0 for all x belongs to real numbers. So whatever may be the value, you substitute there in place of x. So this is positive, x power 4 is positive, x square is positive. On the whole, it is strictly greater than 0. Even it never equal to 0. It's strictly greater than 0. That means what? Slope positive means what? Slope positive means what? Tan theta positive. Tan theta is greater than 0. Understand? Tan theta greater than 0 means what? Theta should lie, make an acute angle. So theta should lies between 0 to 90 degrees. Okay, now that means even though you draw the tangent, it will be acute angle. It is making acute angle, means what? It lies between first quadrant. Okay, now so tan theta, here we got positive value. So positive value means what? The inclination will be 0 to 90. Okay, now so 0 to 90. So don't think that we should go to third quadrant, all silver teacups. We should not go to third cup. Why? Because the inclination lies between 0 to 180. In 0 to 180, from 0 to 90, tan is positive, first quadrant. That's why it makes an acute angle with the x-axis. Okay, now so I hope that you understand this problem. Solution. Let us see one more problem. Welcome to this problem. Find the equation of the normal to the curve y is equal to modulus of x square minus modulus of x at x is equal to minus 2. Let us see here equation of the normal to the curve. So before starting deep, don't directly start the dy by dx. So let us see this modulus, how to remove this modulus. At x is equal to minus 2, he is saying. So at x is equal to minus 2 means what? So this is a minus 1 and minus 2. That means what? In the neighborhood of minus 2. So if you see the neighborhood of minus 2, all are negative values only. That means what? X less than 0. X less than 0. When x less than 0, mod x is equal to minus x. Mod x is equal to minus x. That means y is equal to modulus of x square. Mod x is equal to minus x. Already minus is there, plus x. Okay, now right. Again, you in the neighborhood of x is equal to minus 2. See here, observe here. Let us take any point in the neighborhood of this minus 2. Minus 2.1. If you take a minus 2.1, substitute here minus 2.1. So this is a minus 2.1 whole square plus minus 2.1. Minus 2.1. That means what? Minus 2.1 whole square means what? Definitely you will get here minus will become positive 4 point something you will get. 4 point something. 4 point something minus 2 point something, it is positive. That means what? X square plus x is greater than 0. Therefore, x square plus x is equal to modulus of x square plus x is equal to x square plus x. Okay, now in the neighborhood of x, if you take a some any small value that is nearer to the minus 2.1 whole square plus I am finding this minus 2.1 whole square plus of minus 2.1. So, that is equal to positive value you will get. Therefore, this value will be, so y is equal to x square plus x. This is your final function, y is equal to x square plus x. Afterwards, you know that how to find out the equation of the normal. Okay, now find out the slope of the tangent. So, that is equal to dy by dx is equal to 2x plus 1. So, therefore, m is equal to 2 into minus 2 plus 1 minus 4 plus 1, it is a m. Therefore, what is the slope of the normal? That is equal to 1 by 3. So, you know the point slope, point is equal to what? Y is equal to, in place of x, substitute minus 2 whole square 4 minus 2, this is equal to 2. Therefore, minus 2 comma 2. X value minus 2, y value 2, minus 2 comma 2. Slope is this. Therefore, y minus y1 is equal to m into x minus x1. Y minus y1 is equal to m into x minus x1. So, this is a 3y minus 6 is equal to x plus 2. Take to the side, x minus 3y plus 8 is equal to 0. Okay, this part anybody can do. The thing is here very important. Removing the modulus, very important. So, here as x is equal to minus 2, x is equal to minus 2 we have to find out. So, in the neighborhood of minus 2, we have to check. In the neighborhood of minus 2, x is less than 0, therefore, mod x is equal to minus x. So, first we remove the inside modulus. Afterwards, how to remove the outside modulus? Okay, now, so this how to remove this. So, we will check it here. So, in the neighborhood of minus 2, take any one point, minus 2.1. So, minus 2.1 whole square plus minus 2.1. It is always a positive quantity. Definitely, you check for any value, it is positive. So, therefore, from that, we got the answer. Okay, now. So, I hope that you understand this solution. Let us move to next problem. Welcome to this problem. Find the equation of tangent to the curve y is equal to sine inverse of 2x by 1 plus x square at x is equal to root 3. So, let us see the solution. So, y is equal to sine inverse of 2x by 1 plus x square at x is equal to root 3. Why I am taking this problem is, generally students they immediately start doing dy by dx. So, sine inverse of x 1 by root of 1 minus x square, again u by v formula, like that they will do. So, do not do that like that. Okay. So, let us simplify this. Y is equal, this can be written as pi minus 2 tan inverse of x, 2 tan inverse of x when x is greater than 1. So, when x is greater than 1 only, here x value is equal to how much? Root 3. Root 3 means 1.732. Therefore, it is a greater than 1. That is why y is equal to pi means pi minus 2 tan inverse of x. This is a formula is there. So, you have to use this formula. So, once you go through the inverse trigonometric functions. Now, find out dy by dx. So, dy by dx is equal to minus 2 by 1 plus x square. Minus 2 by tan inverse of x derivative 1 by 1 plus x square. Okay, now. So, afterwards find the slope of this. Next we have to find out the slope of the tangent. Slope of the tangent is equal to minus 2 by 1 plus x value root 3 whole square 3. So, therefore, minus 2 by 4 minus 1 by 2. So, this is the slope of the tangent. Okay. So, what is the y value? So, y is equal to pi minus 2 tan inverse of x means how much? Root 3. So, x means root 3. Okay. So, then what is the value of this? So, this is equal to pi minus 2 into tan inverse of root 3. Tan inverse of root 3 means how much? 60 degrees. So, 60 means pi by 3. So, 3 pi. So, this is equal to pi by 3. Okay. 3 ones are 3. 180 minus 120. 180 minus 120, 60. So, this is pi by 3. So, therefore, what is the point? What is the point? Root 3 comma pi by 3. X value is root 3. Y value is pi by 3. Okay, now what is the equation of the tangent? Y minus y1 is equal to m into x minus x1. So, this is the equation of the tangent. Okay, now. So, from this problem what you have to observe means, given any function, don't try to directly find the dy by dx. Use these formulas. Okay, can we simplify this? Yes, we can simplify this. Okay, then the problem will become very easy. Okay, I hope that you understand this solution. Let us move to next problem. Welcome to this problem. Find the equation of the tangent to the curve y is equal to x square into sine of 1 by x, where x not equal to 0. If x is equal to 0 at the origin. Okay, now, so let us take the solution. So clearly the function is a continuous at point x is equal to 0. F is continuous at x is equal to 0. Previously we proved this here. Left hand LHL is equal to RHL we proved. That is limit x tends to 0. X square into sine of 1 by x is equal to 0. That is equal to f of 0. Okay, now let us find out the derivative of slope of the tangent. That means what? F dash of 0. That means limit h tends to 0. F of, let call it as just I am writing formula a plus or a. F of a plus h minus f of a whole divided by h. Here at the origin means what? X is equal to 0 we are checking. At x is equal to 0 we are checking. That means what? F dash of 0 plus is equal to limit h tends to 0. So wherever a is there, substitute h, 0, f of h minus f of 0 by h. So that is equal to limit h tends to 0, limit h tends to 0, f of h by h. F of 0 value is 0. Why? Because it is a continuous function. Okay, now, right. So this implies limit h tends to 0. F of h means how much? H square into sine of 1 by h by h. H square into sine of 1 by h by h. So one h you can cancel as h approaches to 0. So this value is equal to 0. This value is equal to 0. How can you say that? See here, you can do like this. Limit h tends to 0 into h. Limit h tends to 0 sine of 1 by h. This is a 0 into any value between minus 1 to 1. Any value between finite value. Limit h tends to 0 sine of 1 by h. It is a finite value, so you will get 0. So what is the slope of the tangent is equal to 0 at the point 0 comma x is equal to 0, and at the point y also will become 0. Okay, now. So therefore I hope that now you know the slope of the tangent, you know the point, find the equation of the tangent. Okay, now. So I hope that you understand these concepts and based on some problems. Let us see some more concepts, some more problems in the tomorrow's class.